Materials, they are a bit funny in that sense. When you say materials to people, it's always that you get the different answers what it might mean for you. For somebody, it's just a steel grades. For somebody, it's about advanced materials like neodymium magnetics or something like that. So it really heavily depends on who are you talking to. Also, the properties of material that you're interested in is very variable. Some of the people are interested in, let's say, fatigue properties, but another individual might be interested on, let's say, the magnetic properties or electrical properties of the materials. So it's like a interesting question that, okay, materials, but what do you mean by that? And typically with the companies, the material-related activities in the are kind of goes in either you have a product failure or you want to just find a second source for some scarce material that there is currently one supplier only, and if anything goes wrong with that one, I need a new one, an alternative material perhaps. Then if you want to develop a new product, then sometimes the existing kind of solutions don't really cut it. You just have to have a bit more advanced approach for it. Then on the other hand, you might have in-house initiatives like cutting costs or making products more green and so forth. Or you might have even the in-house material development where you are trying to develop, let's say rubber compound, let's say composite, or some kind of fun other, let's say, mixture of alloys, which then produce the solution for your product kind of challenge. But for all of these questions, it goes really down to okay, what are the materials out there and what are the properties for them? Next one. And on the other hand, in the simulation field, we quite often go and we optimize our constraints, loads and have multiple load sets and boundary conditions and everything. But then you ask, okay, how about material? Yeah, we made that out of steel again. And then somebody shouts out at the back row that says, okay, how about aluminium? And then you're like, okay, maybe, but maybe I just simulate that with the steel. So question is, how would we have it so that actually we can optimize the material selection as well in order to get the optimal product with us? So how do we involve material selection to the product optimization loop is kind of the key question here. Next one. And if you go forward, skip the animations, one more, and one more. So typical approach is really that you have an ongoing issue at your hands, and then you start having a discussions. And since you do have some in-house expertise, some of the people have very used to kind of use just one kind of a material or one kind of a solution. Guy on the back row is shouting aluminium, and everybody is going for aluminium instead of thinking out of the box that how about if we would in this time use, let's say, some plastics or polymers instead to make it product perform a bit better and have a better kind of cost point for it as well. So the question is, how do we make kind of informed decisions based on the kind of challenges what we have? There's a vast array of data available. Next one. We can skip this one, please. And this one as well. It seems that my hiding of the slides doesn't really work. And if you click once more, you will get one extra box in there. Thank you. So what I suggest here is that where we jump is the systematic selection of materials methodology. In the same way, how we define what is the best possible, solution for, let's say, some stress strain, situation like product optimization, mechanical analysis, or let's say electrical thermal analysis. We would do same thing with the materials selection. So define the basic function. What is the geometry and primary loading? Is it thermal, mechanical, or electrical constraints? What exactly do you have to meet? Is it the kind of a maximum insulation value, or is the maximum kind of acoustic damping, or what do you want? And then objectives like what do you have to minimize or maximize? Is it the cost of the product, or is it actually product performance, or minimum bending, or capability of conducting a largest amount of let's say signals through the system? What is the objectives? And then start screening from all the materials, let's say, in the world. Get the top candidates, and then start digging even more deeper and deeper for the exact material definitions. What can you have? Next one. And if we put this in the, let's say, some kind of fun use case, so click few animations forward. We have an electrical connector, which has some requirements like temperature resistance, so it doesn't melt. Second of all, it has to have a low dielectric constant, so it doesn't start alternating the electrical signals too much. On the manufacturing side, it had to be injection molding so that we can make millions out of them. And then, of course, RoHS reach, since all that what compliance and requirements must be met in order to make it happen. And of course, the objective of all this design is minimize the raw material cost. And if you know by today that it's polyethylamide as a plastic, question is what is the best possible material for this kind of use case? What kind of performance can I get from it, and do I get any cost kind of benefits for it? So if we go and look at the small video, which I believe comes next, we will see in here at the Ansys Workbench environment, one is having a Granta selector, kind of an application connected to that one, and then you open it up and start searching for connectors as a general thing, going for materials universe database, and in here you can say that, okay, polyethyl are typically used as in the connectors, electrical connectors kind of a design. So, and then you take a look at the data, you will find out there's price data, there's also mechanical properties in there, there's an impact and fracture properties, thermal properties. And then my video is lagging a bit behind me. Let's say multiple kind of fun properties for the system. Oh, it seems that my video was paused. And you even do have a healthcare and food and all restricted substances index risks and all that. So we have a current kind of a generic polyethylamide data, and in here we have some brand names like Ultem. And if you take, let's say, some even deeper data for it, you can get there. But on the other hand, you can say that this is my reference material, which I start to comparing with. And then what we do is say instantly that, okay, I just want to have the possible candidates that are injection moldable, since that is my preferred manufacturing method. And then on the other hand, let's have some additional limits like the glass transition temperature and the dielectric constant. So you put a minimum glass transition temperature of 200 degrees, and then electrical properties you are putting here 3.5 as a maximum value. And then what we do is start searching for the potential candidates. And of course, in here, since the RoHS and reach are pretty interesting for us, we are also having those as maximum values. And then if you do something which is a really kind of fun, nice feature of this Granta selector, you start to plotting things against each other. So what do we do here is have electrical properties of the dielectric constant, which you plot against the price of the per unit volume. And if you look at now, you will find out that there's all potential kind of materials in the world, but in here we have the nice ones, which are the polymers. And in here, what we have is the current reference point for polyethylamide, and then some other plastics as well. And as you can see, we have something that like a polycarbonate is having a nicer price point, but also it is still in line when it's come to dielectric constant. And if it turns out to comparing some of these plastics together, we can have this stable view of comparing exactly the particular values that you might be interested in, or particular properties that you might be interested in. And when it comes to simulation of the thing, oh, let's see what we have in here. And if you still go in deeper in the data, you will find out that, okay, it's possible to see that what are the possible kind of manufacturers of the things. And then if you want to push out the material data for the simulation, that is also possible in this case. And if we go back to this workbench environment, what we have in here is the same polycarbonate, and you will see that we have temperature-dependent properties exported from the Granta selector. So you can go to the next slide without running this again. So as an outcome, what we find out is that instead of polyethylamide, we can go to polycarbonate most likely. Just a bit of investigation that if it fulfills all the other kind of requirements for the material. But what we have kind of shown is that if you have analytical approach for selecting materials, it can really pay off when it comes to the material properties, when it comes to product performance things and the price point of your products as well. Can you go to the next slide? Yep. Just run to the end of these things. I think there's multiple animations which I tried to remove, but it seems that all versions are a bit off. So just to summarize somehow the Granta selector for you. So what we have is the encyclopedia of material data in there, which enables you to have an analytical approach for material selection, compare the properties and finding the best candidates for your products. And also we have capabilities like compliance and restricted substances are supported on the material selection process. Can you go forward? And then again, you have animation, something like 7 or 8 in here. So click them through, please. So if you think about the corporate wise, I'm a bit overshooting my timing here, but nevertheless, so if we are thinking about corporate wise, what kind of questions do we have? Materials information. We have a bit of the similar thing what you have in the general product data management. We have let's say disparate data, we have siloed teams, we have raw material issues in there and regulatory compliance. And possibly the question is how can we make this thing better in the corporate level? Next one, please. And one of the solutions could be that one is starting using a dedicated material database for all the materials involved. And of course, this will make kind of for the materials database as a single source of truth for all materials related questions, particularly if you have your own in-house material development, or you have to have a specific properties of the data which is not necessarily commonly available for all the people. And for that single source of truth, it will make sense that what we have is nice. Please go on. If we have a nice integrations to kind of reporting systems like a CAD and the CAE systems, and of course the PLM, where we can feed the downstream systems like MES and ERP. So materials data management starts to be also kind of an important thing for the full product kind of definition and the full digital thread, particularly when we have these regulatory compliance things that you have to feed met the product materials don't contain anything that they shouldn't. So in order to describe fully that, okay, what kind of substances we use at the manufacturing and during the use of the product, we might have to go and have a separate database for materials data, and from there derive the kind of results and materials models for the finite element analysis. Make sure that we are having a product documentation in the CAD so that it refers to same materials, then define the materials in the, let's say, PLM as well, so that they will exactly know the recipe of exactly component that we are using, and thus we are able to feed even the ERP system for it. Next one. And this is pretty much the same thing. So for the centralized system for the materials data, what are the beneficiaries for this implementation are, of course, materials engineers who help the material selection process or development process, the simulation engineers who will get the proper material data and reusing that one every time, so we know exactly what they used for the simulation. Then, of course, product design can reuse the data and select the properly documented allowable candidates. And then, of course, the regulatory and environmental people can really make sure that everything is okay when it's come to for product launch. And all of these can be connected to the Windchill as a product description. Next. If you put it in a nutshell, what we are showcasing here, first one was Ansys Granta Selector, which enables you as a desktop application level to really harvesting all the materials in the world and getting the possible candidates. But on the other hand, the Granta MI is really giving you the accurate materials information for the particular ones that you have ended up with, document that one and make that part of your digital thread. Thank you.